Hi guys, this is Mr. Ivan. So today here we are going to talk about first order differentiation, or rather first principle differentiations. Okay, so this is tested. This is not really tested in most IP schools. It will probably in your quiz, but nevertheless, it's good to understand differentiation from the first principle point of view. Okay, so the concept of differentiation is when we have a curve. So for example, this is a curve and we have this coordinate here P and this coordinate here Q. Alright, and this curve is y equals to fx. Okay, any function fx. Alright, so at this point, let's say the x coordinate is x. Alright, and then this coordinate here would be fx. Now, let's say that q, okay, the x coordinate of q is delta away, okay, from P. So this would make him to be x plus delta. Alright, so the coordinate of P is x comma fx, and the coordinate of Q would be x plus delta, okay, and f bracket x plus delta. Okay, why do we make it like a little bit complicated? This is called the general form, so that you will be able to solve all forms of first order differentiation by when you have the general form. So when we differentiate a function with respect to x, right, we are trying to minimize this. We are trying to minimize the distance between x and x plus delta. So that's why the basic definition of dy dx, right, okay, is equals to the limits of, okay, as delta approaches to 0, okay, the change in y over the change in x. Because as this point goes closer to him, so you realize that you will travel along here and it goes closer to him, such that we are trying to make the delta approach to 0. Okay, then we can find, okay, what is the derivative of the function. Okay, so this is the basic definition. Dy dx is the limit of the change in y. Okay, this is called the change in the y over the change in x. Okay, so remember, dy dx is equals to limit as delta approaches to 0, the change in y over the change in x. Okay, so now how can we apply it to a question? This would roughly be how the question will look like. Okay, given that y equals to 7x plus 4, okay, find, okay, its derivative using first principles. Okay, so once you see this word first principles, you're going to use the definition. So first thing, what I will encourage you to do is always let fx to be the function, so which is 7x plus 4. Alright, then, so this guy, remotely, remember on top there is a P and a Q. This guy would actually be your coordinate of P. Okay, now, so coordinate of Q is how far away? Is delta away. So fx plus delta would be equals to 7 open bracket x plus delta, okay, plus 4. Alright, and this guy will actually be your q. Okay, so what is the definition of dy dx? Remember? Okay, so we write down now. Dy dx, which is your first derivative, is equals to the limit, okay, as delta approaches to 0, your change in y over the change in x. Alright, so what would be the change in y? So p and q, who will have a bigger y? So q will have a bigger y, so I will use 7 bracket x plus delta plus 4. This guy is my q, minus 7x plus 4. Okay, over, so this guy is the change in y, the difference in y. Now what about the change in x? So if you look at the top right, this guy here is the change in x. Okay, and the difference between the point here to the point here is always delta. So the denominator, right, is always going to be delta. Okay, oh, I forgot to let in my limit as delta approaches to 0. Okay, now if delta approaches to 0, right? If delta approaches to 0, it means my denominator is goes to very, very small. Okay, so we all know that denominator cannot be 0, but it approaches to 0 means it cannot reach 0, but it will be very, very close to 0. So this is why we are trying to find the behavior, okay, of delta y and delta x. All right, so I do some manipulation. Okay, 7x plus 7 delta plus 4 minus 7x minus 4 over delta. Alright, then you realize that, okay, approaches to 0. 7x minus 7x gone, 4 minus 4 gone, you are left with 7 delta over delta, okay, which would be if u equals to 7. Okay, because the delta now is gone. Alright, so and of course, based on your technique of differentiation, you already know that when you differentiate 7x plus 4, right, which is this guy, you will get 7. Okay, so this is how you verify. Check with this. Okay, so this is for linear equation. Okay, this is for linear equation. Now, example 2, if I have a polynomial equation, okay, so for example, let's say y equals to 1 over x. Alright, and I want to differentiate y equals to 1 over x using the first principles differentiation. Okay, same thing, always define your fx first. Always let the fx be equals to your equation. So fx plus delta would be equals to 1 over x plus delta. Okay, if you're not comfortable with using delta, it's fine, you can use a, as long as you know what you're doing and the notations are correct. Okay, so definition of dy dx again, guys, is the limit as delta approaches to 0, your change in y over the change in x. Okay, so in this case, what is the change in y? Okay, delta approaches to 0, change in y is 1 over x plus delta minus 1 over x. That is the difference in the y over difference in the x is always delta. Okay, so the difference in the x is always delta. Okay, delta is always the denominator. All right, so for my numerator, so I will just transit here so that you can have a clearer picture. Now my numerator looks a bit messed up, so what do you think I should do? I will make a common denominator. So this will become x minus x plus delta over x bracket x plus delta. Yep, over your delta. Okay, so I remember I always tell my students, do not use too many fractions in one equation. So this longer over we will treat it as a divide. Okay, so for my numerator it would become x minus delta, okay, over x bracket x plus delta. Okay, then over, we treat the over as a divide by delta. Okay, so next step would be minus delta over x bracket x plus delta times, okay, 1 over delta. So in this case, delta and delta cancel. What are you left with? You are left with negative 1 over x plus delta x bracket x plus delta. Actually, I forgot to write the limit, and this is one careless mistake that many students forget. So remember to write your limits. Okay, limit as delta approaches to 0. Okay, and now because of this, the limit definition comes into play. We are trying to make delta as close to 0 as possible, such that it becomes negligible. So this guy will become 0. So my final answer is negative 1 over x squared. Alright, so so it's best to conclude that d dx of 1 over x is equals to negative 1 over x squared. In fact, if you do your technique of differentiation, you also realize that you have to be correct in this way. Okay, so all in all, I went through with you 2 ways to do first principle differentiation. Okay, now always remember the concept is dy dx is equals to the limit as delta approaches to 0, your change in y over the change in x. Okay, and for linear function, okay, we cannot have the delta as the denominator only, okay, because delta approaches to 0, it will become negligible and it will result in an error, so we have to try and cancel the delta away. For polynomial kind of function, we will try to make a common denominator, okay, and then as long as the denominator does not have delta only, we can assume that delta approaches to 0, which is becoming very small such that it's negligible, so that's why we don't take the delta anymore at this step here. Okay, feel free to revise yourself, okay, and then let me know if you have any questions on my Instagram.